Welcome to Introductory Geology Lab. This is sort of the elements of geology. And in a introductory course like this, it is very important to begin with a study of Earth's materials. And so we will be taking a look at, in this first lab, minerals and several representative families of minerals, their characteristics, sort of their physical diagnostic properties. And so you'll be really studying a nice selection of minerals here to give you a good feel of the basic building blocks of rocks. So the best place is to start with a study of our minerals. And so to take a look at, you've got a handout here, the Earth Science Lab, just what is a mineral. And so right here we've got kind of a set little definition, or what the properties are that we're looking for in that what we would call a mineral. And so first off, they must be naturally occurring inorganic solids that possess a definite chemical structure. This gives them a unique set of properties, internally and expressed many times externally as well. So to look at that again in your handout here, we've got naturally occurring. So even if a substance has an identical chemical structure as a mineral, if it is man-made, it is not considered a mineral. So they do have to be naturally occurring. Also, they must be inorganic and solid. So inorganic just means that it's something that's never once been living. Organic is sort of the study of life. So inorganic and solid. So for example, water in the solid form, meaning ice, is considered a mineral, but liquid water is not. So it does have to be in a solid form, and it has to have a crystalline structure. And so even if outwardly it does not look like it has crystals, internally it does have sort of a crystal lattice type of a structure to it, a three-dimensional network occurring internally in the arrangement of the atoms to form molecules and how they bond. So it does have to have a crystalline structure, and of course a unique chemical composition throughout, and that can vary just within a limited range. So they have a definite kind of chemical composition to them. We'll actually in our lab be studying 30 minerals, and we do have actual samples of these in the laboratory, and I highly recommend that, if at all possible, do come to lab and actually handle these, physically handle them. That's the best way to get a feel for and have a better understanding in the study of these minerals. So if you do get that opportunity, do come to class and actually handle our minerals. Okay. Now, it's just a great idea to explore the minerals in the tray, kind of find ways that they might be grouped. Do we have similar colors? Do we have similar shapes? Crystals, crystal forms. So numerous ways that these can be grouped, but just trying to group items, place them in a particular kind of order, that is something that we just do as humans out of our curiosity. But just in looking at the handouts, we're going to notice that on the next page of the handout, you'll see that it's going to list many physical properties that we will take a look at. We'll kind of go through each of these. This is page 2 of the handout. In looking at their physical properties that can help us be very diagnostic in the identification of our minerals. Just real quickly here, if we look at that, we see crystal form. We'll be going through each of these. Color, this would be the outward color. Something called streak, which is actually the powdered color of your specimen. Luster is another one. The manner in which light gets reflected from it, the surface of your mineral. If we looked and continued on to page 3 of your handout, diaphaneity, so how much light is actually going through or being blocked by the mineral. Hardness, so how does it stand up to its abrasion, its a resistance to abrasion. That's considered its hardness, and there's a scale called Mohs mineral hardness scale that we'll take a look at, and that's very diagnostic. When you're not sure about a mineral, they may look very similar. Some of our lighter minerals look very similar. Using the hardness scale can really help you distinguish and kind of rule out what it might be, what it might not be due to its hardness. So that's very important. Another one, we continue on to page 4, cleavage. So cleavage is a manner of how does it break, so the breakage of it. Will it cleave into basic geometric arrangements along weak bonds, or will it just sort of fracture? At number 8 there, random sizes. Okay, so that'll be something that we'll look at. Its specific gravity, so what is its heft? What is its weight relative to a gram of water, let's see, an equal volume of water? That's a specific gravity. And does it have any special properties? And so we'll look at several of these: magnetism, taste, odor, striations, double refraction, and on that 5th page, the solubility in hydrochloric acid is another telltale for some of our minerals on it, and really helps to identify them. Has to do with their chemical content and whether they react with an acid, so that's important. Just looking through the handout there. On page 6 of the handout, if you take a look real quick, this is the mineral quiz, and so this is actually the handout sheet that I will be giving you on the quiz. And so here you have it, you know, a little ahead of time here to see what it's going to look like. But this quiz, and we'll have more to say about that in a bit, it will be a hands-on, practical type of exam where you'll have mineral samples and you will need to be able to identify them and give me some of the physical properties that we'll be going through. And so as you can see here, we do have the names of the minerals listed. So as far as spelling goes, you won't have to memorize how to spell them. Kind of have your little word bank here of the minerals listed. And notice you've got 25 questions here, a part A and a part B. So that means there will be 2 questions about each mineral for you to identify. And some of the things we could ask you were those physical properties that we're running through very quickly there. What is its hardness? Does it break or does it fracture? When it breaks, does it cleave or does it fracture? We'll go through that. What is its streak color? What is its luster? Metallic or non-metallic? Again, we'll be going through these. Does it have a special property? So these will be some of the questions I could ask you, but really the most important thing will be for you to first identify, well, what is its name? You know, you need to be able to identify these. So that's why I'm really stressing that we need to be able to come into the lab and actually work with these. I'll be showing them to you in our video, but there's nothing like getting your hands on these earth materials, these minerals. So So there's a page in there. That's a setup of what the mineral quiz will look like. This is actually the handout you'd be given. And so several questions will go with that. On page 7, this, you can't quite see it all in one frame, is a key for how the minerals are placed in the boxes that I have provided for you. They're numbered in this manner. So for example, the graphite would be number 1, galena number 2, pyrite number 3, etc. As we go through here, maybe I can change the magnification, get that all in there if possible. Not quite. There we go. So here's our key. Okay. And so as you study these, the minerals they do have a little number on them. Number 14, sodium pelagic clays, feldspar. That is going to be on the actual sample so that you can study these and learn these, and they're in order by these numbers. Now, on the exam, on the quiz, they won't have those little numbers on them. So it will be very important for you to learn these. And so if I can just set my tray of sample under here, I don't know if I can get them all in there, maybe. But again here, so our number 1, okay, as we can see, there is a number 1 on there. That's our graphite. Number 2, it's very shiny. Kind of have a glare on the light. Oh, and it's very heavy. That's number 2, galena, and etc. Number 3, another little sparkly one. That is pyrite. Over here, number 4, magnetite, and so on. So each of these are numbered according to the little handout key that we have. So 13, 14, 15, etc., 16, 17, and so on. Okay, and that's how they're numbered in the tray. 27 dolomite, 28 fluorite, 29 kaolinite, and 30 talc. Okay, so these samples do match up with our key. Okay, and so there's nothing better than actually getting your hands on those samples so you can turn them in the light, see how light reflects off of them, and so forth. So this key does go through and match our tray sample. Okay. And the next page in here, we'll get to these, but page 8 in there is talking about the different types of breaking and looking at how they cleave. So in one direction, 2 directions, right angles. So we'll look at those when we talk about cleaving, and whether they do cleave or whether they fracture. Then towards the end here, this is page 9, just a nice little synopsis of some of these. We'll be actually getting some of this. We'll go through the hardness. We'll make it very simple. Streak, we'll get some colors on a few of those. But it just kind of gives you the various chemical compositions, but you won't really have to know those chemical compositions. It's good to have a general idea, but no reason to memorize those chemical compositions whatsoever. But a metallic luster, a non-metallic luster, all of these kind of physical properties, how they've got them divided up. This would be page 10. It continues on. Whether it cleaves, fractures, what its hardness is, any specific type of diagnostic property. All these things together can just really help you identify these. The last couple of pages, this would be, I believe, page 11 and 12 on here, is just a place for you to write some notes if you would like to use it. You know, you could write your sample number along here. What is its luster, its color, streak, the hardness. Now, as far as whether it cleaves here, we're not going to need to know the number of cleaving sides nor the angles. Okay, we won't get that detailed. But whether it has a special property, that would be something we might want to note. And then the mineral names, of course, that match with your sample numbers. This could be a good way to organize your data if you would like, and there's just a couple pages of that for you since we do have 30 samples. So that's a brief run through of the handout and how it's organized. And so we'll kind of start looking our way through our samples, the various physical properties, the diagnostic properties, and we'll get to begin that in looking at those. And so take a moment, maybe just go through your tray and the key and start learning some names. It's very important to begin learning the names of our minerals. The foundation for studying geology is the ability to identify minerals which are contained in rocks. So the best place to start is to identify the minerals. And like I mentioned before, we do have several physical properties that we want to look at. It would be on page 2 would be where those begin. And starting off, we would take a look at the crystal form, kind of down along here on page 2, crystal form. And so the crystal form, minerals may have very smooth, well-developed crystal faces if they are allowed to grow in open spaces. So sometimes we don't necessarily get good crystal faces. But the expression of the various crystals are stemming from the internal chemical arrangement, the bonding of the atoms and the ions within the mineral. And if we are given enough space for our minerals to grow, they will develop some very nice crystal faces. And so, for example, in our trays, the quartz family here, we've got several samples of the quartz. Number 19, the amethyst quartz. Number 20, the milky quartz. Number 21, glassy quartz. And number 22, smoky quartz. Well, some of these might have nice crystal faces, some of them may not. In our trays, most of our number 21, our glassy quartz, tend to have a very nice crystal form to it, sort of a hexagonal shape to it. So this is the glassy quartz. There's one sample of it that's pretty nice. You can see the hexagonal kind of shape to the crystal. Here is another sample that I have of the glassy quartz. They seem to have the best crystal faces on them. Sort of a nice hexagonal look to them. So number 21, the glassy quartz, is a good example of crystal form. Now we have some that are actually very small. I'll see if I can magnify them for you a little bit. But the number 5, specular hematite. Okay, the specular hematite here. Very small crystals. We'll turn that number 5 around for you there. Try to maybe do a magnification here of some of those very small crystals. Very sparkly, but you can see many crystal faces there. And that's the sample of the specular hematite. Very shiny, speckly, specular hematite. Good way to remember that one. Another nice one is the number 3, pyrite. Some of those are very small on there, but again we have another very nice crystal face on many of those. Very shiny, kind of golden color pyrite. It's also known as fool's gold because of that kind of yellowy sheen that it has. It has fooled many a miner thinking this was gold, but it's known as pyrite. So those are sort of the crystal form that some of our minerals can have, and that can be very diagnostic, but it's limited if you don't get the space afforded to allow those crystals to form. So that's one option to help you out. Color is the next identifying property on our little handout here, color. It's a very obvious physical property, but can be useful for, again, we showed you the pyrite. Here's the galena that they're mentioning. Galena would be number 2 in your tray. Galena has sort of that grayish, very metallic looking sample there. And they also mention olivine. This would be number 18 in your tray. Olivine. Wow, it kind of has this olive green color. Olivine. And so these can be good, but it's limited because the color of many mineral species, such as quartz, for example, we did mention many of the quartz in here. We showed you the glassy, but here's a smoky quartz, sort of a brownish hue to it. Here's the amethyst quartz, the number 19 in the tray. Kind of that purple color to it. Milky quartz is another one, number 20 here, the milky quartz. And of course we had the glassy quartz as well, but many varieties here of quartz. They're all the same chemical composition, but they have slight little impurities in them that give them variation in color, okay, even though these are all quartz, and they have variation of the color. So again, color can be good, but it's not completely 100% the best for identification. It can be misleading. Sometimes the surface gets weathered out in nature, and it can modify the coloration of the minerals. So it is the very best to observe color on a fresh, unweathered kind of surface. And what is even better than the outward color of our samples is the powdered color of our samples. So this would be number 3 in our handout, okay? The streak. It's the color of the powdered portion of our mineral. And it's very diagnostic, more so than that overall kind of outward coloration. We can get the powdered form by rubbing it on the quarter of the what we call a streak plate. This is just a unglazed porcelain tile known as a streak plate, and this powdered form then will give us a nice diagnostic tool here, as we will see. Now, a lot of the lighter colored minerals really won't show up on a white streak plate, so unfortunately that's not going to be very useful in diagnostic value for identification, but we do have some that will powder up very nicely. Also, some of our minerals are very hard. They're harder than the streak plate, so they're not going to powder up and leave behind a residue. But for those that will powder up and give us a nice color, can be very, very useful. And so that would be the minerals numbers 1 through 7 in our tray. Okay, so starting here, 1 through 7, graphite, galena, pyrite, magnetite, specular hematite, earthy hematite, and limonite. Those will powder up very nicely, and we should be able to get a nice streak color for each of those. And so that's what we'll want to do, and just kind of write down what the color would be. See, I've got number 1 here. This is the graphite, number 1, which actually is a carbon, pure carbon substance. Graphite is what is in pencil lead. Okay, and so that gives us a sort of a gray to black streak color. Okay, that's number 1, galena. I'm sorry, graphite. Number 2 is galena. Okay, the number 2, galena. This one, go ahead and do the streak for galena. And again, galena here is going to give us again, sort of a black to gray colored streak. This is a lead sulfide, and it gives you that black to gray streak color, the powdered version. Our number 3, pyrite. So there's our pyrite, number 3 in our trays. Has sort of that goldish yellow color, right? But if you notice the powdered version of this, okay, the powdered version of pyrite is again a gray to black color, okay, and this is the pyrite. And so if you are out mining for gold and you come across a golden nugget kind of like this and you think you've got a hold of gold, well, gold, actual gold, would leave a yellow colored streak. The pyrite's going to give you this gray black streak. So that's a very easy diagnostic test to find out whether you have gold or if it's just some pyrite that you've come across. Okay, so pyrite number 3 leaves a sort of a gold, or I'm sorry, a black to gray color on it. And you might want to record these colors somewhere. Okay, the number 4 is our magnetite, and it, color there, if I can get a good spot, powder up. That also is leaving a gray or a black streak as well. A little bit lighter gray streak. That's the magnetite number 4. Specular hematite, so this is our number 5, the specular hematite with all the little speckles on it. Let's see what it does for us. This one is leaving, I would say, more of a, it's also looking kind of like a black to maybe a brownish color, a little more on the brown side would be our specular hematite. Not quite as gray or black as the other ones. So these have a little more iron, and it's sort of an iron oxide to it, a little more of a rusty looking color. Specular hematite, I'll go with maybe a brown on that one. Earthy hematite, okay, this is our number 6, earthy hematite. Let's go ahead and do that one. That one, yeah, has more of a red-brown color to the streak. That's right here, more of a red-brown for the earthy hematite. And then number 7 out of your tray, this is the limonite. Okay, let's see what it's got. Actually has a little more of a yellow color to it. So number 11, limonite. I would go with sort of a yellow brown or maybe even an orange brown color to that. So those are the only ones that give a good streak color. So that would be 1 through 7 in your tray, and you want to note the color of each of those. You would be given a streak plate on the exam, and so if you were asked the streak color of your sample, you could very easily just rub it against the glazed tile here, our streak plate, and then report the color that you find. So that's the streak color diagnostic test, and I would ask you, what is the streak color? Okay, so a simple little diagnostic test for the powdered color of our samples. Okay, so that's the number 3 there, diagnostic property of streak. That would be one that I could ask you on the exam. Luster, this is the manner in which light is going to be reflected from the surface of our minerals. And that's known as luster. And there are two very broad categories. One is known as metallic, meaning it would kind of reflect like a metal, and the other is considered non-metallic. Okay, they do subdivide that into many other descriptive terms such as vitreous, pearly, greasy, and some other things like that. But we will just focus in on whether it is metallic or non-metallic. Okay, so there's sort of a table here, metallic or non-metallic. And you might note that there's a couple on here that I'm going to give you that fall into a couple different categories, something like limonite and graphite. They might not follow exactly this table here that I'm going to give you, but the ones that we just did the streak color on, so 1 through 7 in your tray, we're going to make this very simple. So you'll want to make a note that numbers 1 through 7, okay, in our tray are going to have the metallic luster, and 8 through 30 in your tray are non-metallic. So if you can just memorize that 1 through 7 in your tray have a metallic luster, well, if it's not 1 through 7, then you know they're going to be non-metallic. That's an easy way to try to learn. Just learn those 7, those that are metallic, and if it's not one of those 7, then you know the luster is non-metallic. We'll make that pretty easy. So it's either going to be metallic or non-metallic. I could ask you that question on the exam. So if I do ask you luster, your choices are metallic or non-metallic. And those that are metallic that we are going to call metallic are the graphite, galena, pyrite, magnetite, specular hematite, earthy hematite, and limonite. We're going to call those metallic, even though they may not obviously be, not all of them might be obvious metallic, like galena here, number 2, is a great example of the metallic. Okay, seeing how the light reflects off of that. Okay, so 1 through 7, make yourself a note that those are a metallic type of luster. Okay, diaphaneity, that's the next thing on our list here, number 5, diaphaneity. That's the amount of light that passes through the specimen. That's known as diaphaneity. And it's described as, we've got several things here that describe it, whether it is transparent. So being transparent means that you can see through it. Something like a window. Light will go through it. You can see on the other side of it with clarity. So that would be transparent. Some of our samples of number 11 here, calcite. I can find it. Here it went. This is a nice example here of calcite. You can see fairly well through there. Some of the specimens are a little better than others, but you can kind of see that letter on the other side of the calcite. You can see that letter C there. So calcite is a good example of being transparent. Light goes through. You can kind of see what's on the other side there with some clarity. Okay, that would be transparent. An example of a transparent one. Translucent. Light passes through, but you can't see through it with clarity. So something like a light fixture, let's say, can't quite see through to the other side very well. An example of that might be the selenite gypsum here that I have. It'd be number 9 in the trays. It's light kind of goes through it, but yet I can't really see on the other side of it. So we call that translucent. Can't quite see through the other side with clarity. Okay, that's translucent. And then opaque, of course, you cannot see light going through it at all. So my galena again, let's say, yeah, no light is going through that sample there of galena. Okay, so that is opaque. Light is not transmitted through at all. So basically, yeah, definitely all of our metallic minerals, metallic luster minerals, are opaque. Light's not going through at all, for sure, on that. Now, really, diaphaneity, we won't be testing you on diaphaneity, but it is helpful. It can be diagnostic in some cases with our minerals. Okay. Hardness. So hardness, let's go to the next one here. Next physical property, I'm on page 3. A mineral is resistant to abrasion is known as its hardness. So how easily does it scratch another mineral, or is it scratched by another mineral? So we had why it's called the Mohs mineral scale here. Back in the 1700s, there was a mineralogist, Mohs was his name, Moe, and he took 200 to 300 minerals and he scratched them against each other. And when he finished, okay, putting piles here and there, he ended up with one mineral that could scratch all the other minerals, and none of the other minerals could scratch it. So he ended up with the hardest mineral, being a number 10 on his scale here, the Mohs hardness scale, being the diamond. So the diamond is our hardest mineral substance. And so he went through and he put sort of a scale with the least hardness ranking as a number 1, and the harder we go, number 5 there, and through 10, the diamond. So he started out with a very minimal hardness, which would be our number 30 in our trays, would be, let's get that here out of the way, or maybe both here, I don't know, the talc. And it's very smooth. So if you take your finger and you rub across that, it feels very soft, very slick, slippery. Okay, because the hardness of skin is actually a 1.5 on this scale. And so this feels very smooth. It's a 1 on the scale. Tends to feel very smooth. You think of talcum powder, how that feels smooth on your skin. Also, graphite, again, is a number 1. So graphite was our number 1 in our tray, but it's also a number 1 on the hardness scale, and it feels very smooth as well. And graphite a lot of times can be used as a lubricant instead of oil in mechanics. Maybe it's even put in an eyeshadow, maybe that silvery color, but it's very smooth, and it's a number 1, so not very hard. It can be scratched very easily. Number 2 on our scale, gypsum is the example that they give us. Okay, so for example, I have the selenite gypsum. It's the 8. We also have our 9. So we have 2 varieties of gypsum here. We've got the satin spar gypsum, beautiful sample. Lots of threads and very fibrous look to it. May not be showing up real well in this video here. Very fibrous look to the satin spar gypsum, and then I've shown you the selenite gypsum before. Those would be our number 8 and 9 out of our trays, and so this is a hardness of 2. Certainly our gypsum could scratch our talc, right, because talc's number 1, but talc could not scratch the gypsum sort of arrangement. Our fingernails have a hardness of a 2.5, as you can see right here. So your fingernail can actually be a very good diagnostic tool. So our fingernails would actually be able to scratch the gypsum. So sometimes between these lighter ones, the calcite, for example, looks very similar to the gypsum, but the calcite, let me get that one out, that's number 11 here. You wouldn't be able to scratch the calcite with your nail because it's a 3, okay, on our hardness scale. So if you needed to, you could use your fingernail. The selenite, the gypsums would scratch with the fingernail, but the calcite wouldn't because they are kind of similar looking. So you could use that method to kind of determine and identify your sample by using the hardness scale in there. So hardness of 3 would be the calcite. Okay. What else do we have on our list? The fluorite would be number 28 in your tray. Okay. Has a number 4. Certainly your fingernail would not scratch the fluorite. That beautiful sample of fluorite. The fluorite comes in several colors. We happen to have the green variety. Comes in blues, purples, quite beautiful. It's rather soft though. It doesn't make the best jewelry, even though it's quite beautiful, because of its softness. Okay, so calcite number 3. Fluorite would be a number 4 on that hardness scale. And let's see what else we've got. Now we don't have an example of a 5, an apatite, in there. Glass plate, this is interesting to note because we will be using a glass plate. A glass plate is 5 to 5.5 hardness. We're going to use that as our reference to gauge the hardness of our minerals. Okay? If our mineral can scratch the glass, it means that its hardness is greater than 5. So we would say plus 5 for the hardness. If our mineral does not scratch the glass, we would say less than 5. Okay, so we're not going to have to say, oh, that hardness is a 1 or a 2 or a 3. We're just going to say it's either greater than 5, plus 5, or it's less than 5, minus 5. And we're going to use a glass plate as our tool in order to determine the hardness of our mineral sample. Okay. The orthoclase is a feldspar. Doesn't hurt to bring those out. That's a feldspar, number 13. And then we have some other feldspars as well. We've got the sodium plagioclase, and we've got the beautiful calcium plagioclase feldspars. So our feldspars are all along around about a 6. Okay. So they're kind of close to the glass plate, which is 5, 5.5. So sometimes it's hard to get a good scratch from our feldspars, but they should scratch the glass and be a plus 5 there, right? The quartz, most definitely. Okay, so we have all of our quartz samples that we had out before. Here's the glassy, right? The amethyst, beautiful purple color. The milky quartz, and we also had a smoky quartz as well. Okay, so all of our quartz varieties, let me use this one, it's a little smaller. I can fit them all in nicely. Okay, there you go. There's all of our quartz samples. Okay, so the quartz would have like a number 7 on our hardness scale. Now topaz, we don't have any of that. That's a number 8. We don't have the corundum. Corundum would be like rubies and sapphires. We don't have any of those in our trays. And a number 10, of course, the diamond. We don't have any examples of those either in our trays, but these would be very hard. Topaz, corundum, and diamonds would end up being the hardest is the diamond on our scale. So Mohs hardness scale. So how we're going to determine that, what we're going to be using for that is just a piece of glass, which you'll all have access to when you take your mineral quiz. So I've got a little piece of glass here, and we would just want to work our way through. Here's the graphite, and so in class that's what I will have you do is you'll go and you'll try to scratch the glass with that. Well, this was talc. I'm sorry, this was graphite. Number 1, graphite. So graphite was a number 1 on that scale. So of course it's not going to scratch the glass, which is a 5 to a 5.5, right? So this would be, we would just say a -5 because it did not scratch, okay? And we would work our way through the tray. Here's number 2, galena, and we would try to see whether or not galena scratched. No, it doesn't, so that's a -5. We would see whether or not number 3, pyrite. And pyrite leaves behind, and it's might be a little hard to see from where you're looking, but you got to know whether or not it actually leaves a groove behind, and that's showing right there, and you can kind of feel the groove as well. So pyrite would be a +5. It would actually scratch the glass on here. So we would want to go all the way through with all of our samples and find out whether or not they scratch the glass. If they scratch the glass, we're going to say +5. If they don't scratch the glass, we would say -5. Okay, and work our way through our samples. I'm just trying to set these out by the names. Sometimes that's helpful to see the mineral with the names. Okay, and here's our hematite. Okay, so in class we would go through this, and it's really good to do that so you get a feel for how hard you have to press down to get that, because that's something you'd be asked to do on the quiz, right? But I am going to run through what the answers to those should be. Okay, number 10. Sphalerite. Go ahead and set these all out for you so you can at least see them. Maybe like what they would look like in your trays. For micas, it's a rather big piece of mica there, but that's the biotite. I have a number on there. There we go. Number 17 is the biotite. There's the olivine. Fill these all in. We would take the time to take a look at each of these and see whether or not they left a scratch behind. All right. Okay, so that's nice. I don't know, maybe you want to take a picture of your screen there, so in case you're at home and you don't get a chance to come and see all of these in person, you got something there to work with. But let me run through these. I'll give you the answer to those. But of course you'd be given a piece of glass to actually do this test on the mineral quiz. So if it left a scratch behind, we're going to call it +5. If it doesn't leave a scratch behind on the glass, we call it -5. Okay, so I'm going to go through our tray. The number 1, graphite, -5. Number 2, galena, -5. Number 3, pyrite, +5. Number 4, magnetite, +5. Number 5, specular hematite, +5. Number 6, earthy hematite, +5. Number 7, limonite, +5. Number 8, satin spar gypsum, -5. Number 9, selenite gypsum, -5. Number 10, halite, -5. Number 11, calcite, -5. Number 12, sphalerite, -5. Number 13, orthoclase feldspar, +5. Number 14, sodium plagioclase feldspar, +5. Number 15, Calcium, plagioclase feldspar, plus 5. Number 16, muscovite mica, minus 5. Number 17, biotite mica, minus 5. Number 18, olivine, plus 5. Number 19, amethyst quartz, plus 5. Number 20, milky quartz, plus 5. Number 21, glassy quartz, plus 5. Number 22, smoky quartz, plus 5. Number 23, chert, plus 5. Number 24, garnet, plus 5. Number 25, getting ahead of myself, pyroxene, plus 5. Number 26, amphibole, plus 5. Number 27, dolomite, just the pink part, minus 5. Number 28, fluorite, minus 5. Number 29, kaolinite, minus 5. Number 30, talc, minus 5. So those are the hardness of each of our minerals. And again, we're just going to make it easy by saying plus 5 if it does scratch the glass, minus 5 if it doesn't scratch the glass. So when you're asked on the exam its hardness, you'll have your piece of glass. You can actually do the diagnostic test, see whether it does scratch the glass, then you would write plus 5. If it doesn't scratch the glass, you would write a minus 5 on your little worksheet for the answers to those. Okay. Give you a moment to get your notes all in order for this. So that was the hardness scale, and that is a property that you will be tested on. So make sure that you can do that. Next in our handout, on page 4 now of the handout, looking at the breakage of our minerals. And so our minerals will break when force is applied to them. And some of these will definitely break along zones of weakness in that internal atomic structure of our minerals. And so if they do break along those zones of weakness in an orderly breakage, in that if, say, we threw our mineral up against the wall, which we will not be doing that, but if we did, that all of the pieces would break into that same geometry as each other. That is known as exhibiting cleavage, or in other words, the mineral cleaves along these weak zones within their atomic structure. And they do mention here many different directions that these can happen, and there's a handout. It's your page 8 that we'll refer to here in just a little bit, with different angles. So directions and angles giving you different forms, different geometries, and this is all known as cleaving or cleavage. If they just break in a random form, okay, that is known as fracture. Down here, number 8, fracture. Okay, so no systematic zones of weakness in their internal atomic arrangement, and so they just break randomly. Okay, that's known as fracture. So you will be tested on this, and so if you're asked the breakage of your mineral, your choices are cleave or fracture. Okay, so we want to go through some of this so you can get a better idea. for this. And of course I'll give you the answers to that. But on our chart here, this would be page 8. These are the different types of cleaving. One nice example here of cleaving in one direction. Okay, so cleaving in one direction would be our examples of the micas. Okay, see how that kind of peels off like in a sheet-like manner. And so we have our number 17 and our number 16. The muscovite mica is number 16 and the biotite mica number 17. And I don't know how well that's going to show up here in the video, but these are very sheet-like, very thin, very light, sheet-like. And so they will kind of peel off. Here's another biotite mica. Kind of peel off in these little thin sheets. I can almost just lift that apart there. So that is cleaving in one direction. Your micas, the biotite and the muscovite mica. Okay. Cleaving in two directions at right angles. These nice examples would be, one of them would be the pyroxene. Okay, the pyroxene here is a nice example of that. Cleaving in two directions, but with right angles. Okay, so like a 90-degree angle. The pyroxene and our feldspars. So here's 13. We had several varieties of feldspars, if you remember. We'll move that over a little bit. We've also got the sodium plagioclase feldspar. Sort of lighter, whitish, grayish sample of feldspar. And then the very beautiful, if we can get it to show up here in the light, kind of reflects. There it is. Do you see that beautiful iridescence, that bluish hue? Almost like a rainbow kind of hue to the calcium plagioclase feldspar. That's a nice way to tell the calcium plagioclase is that bluish kind of hue that it gives off right there, sort of a rainbow light. But those would be nice examples of cleavage in two directions at right angles. Over here we have cleavage in two directions but not at right angles, and a good example of that would be the number 26 amphibole. That's a nice one for that. Cleaving in two directions, but these are not at right angles, so they're not real blocky kind of looking as compared to the ones that are at right angles, like the feldspars. Okay, that'd be a good example of that. Then several here for cleaving in three directions at 90-degree angles. Something like a galena. So these kind of look more cubic-like. Galena, and they would all, if I was to throw that against the wall, you would get pieces that were cube-like, smaller pieces that were cube-like. So galena, and the halite. Okay, halite is very blocky looking, and halite is actually sodium chloride. It is like table salt, so that would be very salty tasting, which we'll get to taste a little bit later. But that is cleaving in three directions at 90-degree angles. Cleaving in three directions at but a 60-degree angle. This would be a very good example of this would be our calcite number 11. See how that sort of looks like it's leaning a little bit, like a rhombus look to it. Okay, how it kind of leans a little bit, rhombic kind of shape. That is calcite. That would be cleaving in three directions, but at 60-degree angle. Down here we have an example of cleaving in four directions. I really only have kind of the top of this, but fluorite, number 28 in your tray, fluorite would be a good example of this. Okay, Cleaving in 4 directions. Good one would be fluorite for that. And cleaving in 6 directions, this one, sphalerite. So sphalerite is number 12 in your tray, and so sphalerite is a good example when you can get a good view at some of those faces there. See if I can get them to glare a little bit. But that one would be cleaving in 6 directions. Sphalerite would be a good example of that. Number 12 in your tray. Okay, so those are just some nice examples of cleaving, and that was page 8 in your handout. Now, you will not have to say cleaving in 1 direction, cleaving in 2 directions with right angles. You will not have to do that. All we will do is say whether the mineral cleaves or fractures. Okay, so I would like to go through that, each one of these, and tell you whether it cleaves or fractures. And so maybe write yourself a note as you go along. You could abbreviate fractures with an F and cleaves with a C. That might go faster for you. And just maybe you could either write it down on your chart here, or if you recall, you do have some place to put data at the end of your handout. So let's go through that, and I will tell you if it cleaves or fractures, and get yourself some notes. And basically you will have to memorize this. Some of them are a little more obvious, that like the galena definitely cleaves, halite cleaves, the feldspars cleave, and so on, but some are not quite as obvious. So you will want to make a note of these, and you'll have to memorize them. Okay, so let's just go ahead and go through them. Your number 1, graphite, fractures. Number 2, galena, cleaves. Number 3, pyrite, fractures. Number 4, magnetite, fractures. Number 5, specular hematite, fractures. Number 6, earthy hematite, fractures. Number 7, libonite, fractures. Number 8, satin spar gypsum, cleaves. Number 9, selenite gypsum, cleaves. Number 10, halite, cleaves. Number 11, calcite, cleaves. Number 12, sphalerite, cleaves. Number 13, orthoclase, feldspar, cleaves. Number 14, sodium, plagioclase, feldspar, cleaves. Number 16, calcium, plagioclase, feldspar, cleaves. Number 16, muscovite mica, cleaves. Number 17, biotite mica, cleaves. Number 18, olivine, fractures. Number 19, amethyst quartz, fractures. Number 20, milky quartz, fractures. Number 21, glassy quartz, fractures. Number 22, smoky quartz, fractures. Number 23, chert, fractures. Number 24, garnet, fractures. Number 25, pyroxene, cleaves. Number 26, amphibole, cleaves. Number 27, dolomite, pink part, fractures. Number 28, fluorite, cleaves. Number 29, kaolinite, fractures. Number 30, talc, fractures. We'll take a little moment. You need to review that little portion of the handout there, go ahead, make sure you get all your information on that. But on the test, the question would be breakage. And so your answer choices are cleaves or fractures. Okay, and so that may be some memory work. Some of them are a little more obvious than others. If they have a nice little geometry, you might know that that cleaves, but some of them, other ones, maybe not so obvious. So make sure that you got that straight, which fracture and which cleave. Okay. Specific gravity is the next in our handout. This would be page 4 that I'm back on, our physical properties. Continuing with that. So specific gravity is the measure of relative weight, and basically they use water, an equal volume of water, to compare it to. And so we do have some in there that specific gravity can be a very diagnostic tool in there. It's kind of the heft of your mineral, and definitely the galena, you'll notice, is quite heavy for its size. And so galena actually has about a 7.5 specific gravity, where water, is a 1. So comparatively, that is quite heavy. Pyrite, something like a pyrite and a magnetite, they're about a 5, so they're fairly heavy. But something like a mica, these little micas here, these are about maybe a 2. I mean, they're very light. They don't have much heft at all, specific gravity wise. Okay, so specific gravity, it is a diagnostic tool that can really help you, but we will not specifically test you on specific gravity. Okay, but some of the things we will take a look at are these special physical properties. So just a few here and there. Some of our minerals do have these special properties, so I will make a note of some of these that you could potentially be tested on. Might be something you need to memorize, or you could certainly do a taste test or an odor test kind of thing. But these are some special properties that we could ask you. Things like magnetism. So do they have a magnetic property, or are they attracted by a magnet? Taste. So flat out you could taste some of these minerals and could be very diagnostic. Odor. So do they have a particular odor? Yes, we have a couple that do. Striations, so little grooves or lines on the faces of your minerals. Some of those do have that. Something like double refraction, so the play of light going through our mineral can actually kind of split the light and cause a double image kind of feature. So double refraction, some of them have that. On page 5 then, there's one more. There's solubility in hydrochloric acid. So some of our minerals have a chemical composition with carbonate in it, and the acid will definitely react with it, fizzing and bubbling, and it's really carbon dioxide being liberated. So the bubbles are carbon dioxide being liberated off of that chemical composition within the mineral, and our calcite will do that, and dolomite will do that. They are carbonates. Okay, so for magnetism, we have one that shouldn't be hard to remember because of its name. Number 4, magnetite. The magnetite does have magnetic properties and is attracted by a magnet. And so as part of your tools, you will be given a magnet, and yes, magnetite is attracted to a magnet. So very easily you can just find out. Just put it on there and find out if it sticks to it, right? So this one, for example, specular hematite, if I put it on there, nope, it's not attracted to it. The only one in our tray that it's attracted to is the magnetite. So if I happen to ask a question of special property, and you're thinking, it's a dark mineral, maybe that's magnetite. Well, hey, use that as a tool. That will help you identify magnetite right off the bat because of the attraction to the magnet. So this will be part of your toolkit that you'll have is a magnet. So magnetite does exhibit magnetism as a special property. Okay, so magnetite. Taste. Okay, so we do have one that tastes. It's very diagnostic. It is halite. That is number 10 in your tray, number 10. So if you wanted to, you could touch your tongue to that, and it is going to taste salty because it is table salt, just like your regular table salt, sodium chloride, what you put on your french fries, all ground up. That is halite. And let me tell you, when you get to your quiz, say you've had a calcite and a halite, or I don't know, sometimes the selenites aren't this flat, they can look a little more cubey, and you're like, I don't know what I'm dealing with here. Lick it, lick your mineral, and I'll tell you this, that halite, sodium chloride, is antimicrobial. So no bacteria is going to live on that sample, no way. So very antiseptic, and so go ahead and lick it if you have to. It might just get you some points. But anyway, taste is a diagnostic property, very special property of halite. Okay, so you just might want to lick your mineral. See here, odor. So we've got a couple that do exhibit odors. One of them would be kaolinite, okay, especially when it is moistened. So if we were to take our kaolinite and you were to huff a breath on that, kind of moisten it, and then smell it, it would smell very earthy, okay? So that is diagnostic for kind of a special property of odor for kaolinite. Another one, it's not on our list here for odor, but sphalerite. If you take the powdered up version of sphalerite, so your number 12 sphalerite, and you were to scratch that on your streak plate, which you will have a streak plate, scratch it a bit, rub it up on there, and smell it. Give it a sniff. Oh my goodness. That has a rotten egg odor. And it's coming from the chemical of the sulfur content in it. This is a zinc sulfide, sphalerite is, and it will give off a very rotten egg odor if you put it on that streak plate and rub it across it. So hey, if you're not sure if that's sphalerite, even if I'm not asking you a special property about it, and you just don't know for sure what that is, scratch it on the streak plate, go ahead and give it a smell. A rotten egg odor, that is sphalerite. So that's another one that has the special property of odor. Rotten egg sulfur odor. Sphalerite, number 12. Striations. So on the crystal faces, quartz has it, pyrite has it, grooves or lines. These are termed as striations. Kind of reflect off of the crystal faces in there. So let me see if I can get it to show up in the video. Might have a better sample of my glassy quartz here. This one's not bad. Can you see, as I turn this slowly, maybe see if I can find the best. Here. Right in here, if I can keep it steady. All along here. See all those grooves? Little striations or lines along the crystal face. Those are known as striations. Our quartz, if you get a good crystal face on your quartz, that will show up, striations. Your pyrite has very, very, very small crystal faces, but they would as well have these little striations on the crystal faces. If maybe you took a magnifying glass to them. So striations are special properties on some of our minerals. Double refraction. Okay. Double refraction, so that was letter E on our handout. Light going through a transparent mineral, something like a calcite. So calcite does exhibit double refraction. So as that light goes through, see if I can place this over that letter C. Yeah. See how it made that letter C double? I don't know if you can tell too much, so there's the C. And I'll put that over there, and we've got two C's now, one on top of each other. So over some typed print, okay, double refraction. Okay, and there's the letter A and L all doubled, okay, with the calcite. So that mineral is actually splitting the light, that internal structure, as it comes through it, and splits it and gives you that double image. We call that double refraction. And so calcite, your number 11 in your trays, as a special property, has double refraction. So number 11. And then I mentioned the solubility in hydrochloric acid. Again, calcite would have it. Calcite is a calcium carbonate, so it has the carbonate content. Your dolomite as well. Dolomite is actually a magnesium and calcium carbonate. So its mineralogy has magnesium and calcium, but it's a carbonate. So it will react with hydrochloric acid not quite as vigorously as the calcite, number 11, but your dolomite, number 27, which is this pink part on here. This gray part is just a gray matrix. It is not the mineral. The pink part up here is the dolomite, okay, will react with hydrochloric acid. Now, I'm not going to have hydrochloric acid out for you to do that, but it would fizz and bubble and effervesce because it's liberating the carbon dioxide from the chemical makeup of those two minerals. So those were some of the special properties that I could ask you. Okay, magnetism, taste, odor, striations, double refraction, and then of course solubility in hydrochloric acid. So if I do ask you for a special property, it is referring to the minerals that I've discussed here. And so you hopefully have made special note of those, so in case I do ask you about those on the exam. Now real quickly, I'm going to go through the potential of what your exam might look like for you, so you'll have a feel for how that's going to go. Okay, so we'll have the quiz sheet. Right, we'll stick that out here real quick. Place that under here. As you can see, there are going to be 25 questions. Well, 25 minerals, right? But you'll have a question A and a question B for each of your samples. And so that ends up being 50 separate questions, right? Notice that you will have your word bank, as promised, of your minerals. So you don't have to try to remember how to spell anything, but I do want them spelled correctly because you've got your word bank right here. All our different varieties of quartz are on there, our hematites, our gypsums, and our feldspars as well. So be specific about which feldspar, which gypsum, which hematite, which mica, and which quartz as well, okay, when you answer those. So I could ask you the name of the mineral, but I want you to be very cautious because I do not always ask you the name of your mineral. Sometimes we automatically just want to put the name down, but I don't always ask for the name. So keep that in mind. You have to actually answer what I'm asking you on each of those questions. So the name could be one question I ask you, may or may not be. Some other things I could ask you: recall the hardness. So if it scratches the glass, and you'll have a little toolkit you'll have a piece of glass, you'll have a streak plate, and you'll have your magnet. So take your glass out. If you're asked for the hardness, see whether or not it scratches the glass. You would write +5. If it doesn't scratch the glass, you would write -5. And that would be our test for hardness. For breakage, remember I just went through whether it cleaves or fractures, so you might need to do some memory work on that, but that's what I'm asking for if the question is breakage. You would tell me it cleaves or it fractures. For the streak, you've got your little streak plate. You can actually scratch it on there and then give me the color. Lots of those that we did were 1 through 7 in your tray. Those would probably be the ones that I would ask because they leave a powder behind that gives a color. So tell me the color. Black, gray, was it brown, red, brown? You know, we went through that. Luster. So is it metallic or is it non-metallic? And if you remember, 1 through 7 in our trays we called metallic, 8 through 30 non-metallic. So if you can memorize those first 7 as being metallic, you'll have it, right? You'll know those are the metallic and everything else is non-metallic. And then I could ask you a special property. Well, magnetism right there, there's your magnet. But some of these other ones, things like taste. Hey, taste it, you know. Odor, could be kaolinite, could be the sphalerite, right? Striations was one, double refraction was another one, magnetism, of course, was one. So what is the special property? And then you would write that as an answer. So the way the trays are set up for the exam, this is just an example here. We of course would have a mineral inside each of our boxes. I just happen to have something that's 7, 8, and 9. Of course you're going to have 1 through 25 of these. But you know, we would say we'd have a mineral in there. Well, that wouldn't be a good one. Let's say that one. Here we go. Let's just put some of these in here. Well, that wouldn't be good for a streak. I got to get ones that would give us a good streak kind of thing. Let's say these were our minerals. Okay. And now, the minerals will not have their identifying numbers on them. They will not. Okay. But number 7, A, is asking for the name. All right. So, remember you got 2 questions for each one of these. So here's our mineral. And the first question, A, on line 7, A, is the name. So you're thinking, what in the world? That's why I highly recommend you come to class and you work with the actual samples, because getting up close and personal with them will help you identify these better. Okay, so you would give me the name of this mineral and what's its special property. Well, this happens to be sphalerite. We would write the name out. The special property is that it has an odor, right? The scratch of it has an odor. You would continue to work your way. Okay, this would be line 8. Question A is breakage. Notice it did not ask for the name. Not all of these will ask for the name. You got to resist putting the name down. So, what was its breakage? Well, first of all, you got to figure out what it is. What is this? Well, it's a dark mineral. Ooh, I could do a quick test. Does it attract to that magnet? Yes, it does. Oh, that's magnetite right off the bat. That's a good tool right there, that magnet. You'll have one of those. So what was magnetite's breakage? Do you recall magnetite's breakage? Oh, it fractures. What is its streak? That would be B. You know, go ahead and do the streak and get its color. It had a black streak, right? So that would be what you'd put for A and then what you'd put for B. So you got to actually answer the question that is asking. Number 9, what's its name? Do you remember what this one is? Again, it won't have these numbers on them. You just have to know what it is. This is galena. It's very heavy. Okay, very heavy. So that's a good way to remember galena. Okay. And the streak, of course, you would have your streak plate and you could do the test and give me the color of the streak for letter B. So A was the name, B was the streak color. So you do have to make sure that you place everything on your worksheet in the proper order. You may not necessarily be starting with number 1, okay, and you'll work your way through the exam, okay, because we kind of rotate out these actual samples. So this is a practical, hands-on lab quiz, and this is just a estimation of what you would be seeing to kind of give you a little heads up of how you might want to prepare for the exam. Okay. Okay, so I do again cannot stress enough that you should come to class and participate in the hands-on for this, because you'll need to know an awful lot about each of your minerals in order to be successful on your mineral quiz. So with that, if you have any questions for me, please be sure to get with me, and good luck with those.